Welcome to this explainer. All right, let's just jump right in, shall we? Today, we are going to challenge a fundamental truth that you probably learned way back in elementary school geography. We're going to take a closer look at the ground beneath our feet and uncover why the maps you grew up with might actually just be telling you half the story. Honestly, prepare to rethink pretty much everything you thought you knew about our planet.
So let me start off by asking you what seems like a ridiculously simple question. How many continents are there? Go ahead, answer it in your head. Now, most of you probably confidently said 7. But what if I told you that depending on where you grew up, or even what specific field of science you study, the answer could be 4, 5, 6, or even 8? Yeah, no way, right? The truth is actually far from universally agreed upon.
To understand exactly why that is, let's move right into Section 1, the definition debate, counting the continents.
It's kind of mind-blowing to look at the different models that are taught all around the world. I mean, in most English-speaking countries, we learn the classic 7-continent model, right? Asia, Africa, North America, South America, Antarctica, Europe, and Australia. But if you go to school in Latin America or even Greece, you're likely taught a combined America's 6-continent model. They treat North and South America as one single giant America. Meanwhile, over in parts of Eastern Europe and Russia, they teach a completely different 6-continent model that just mashes Europe and Asia together into Eurasia. There's even a 4-continent model out there that lumps Afro-Eurasia all together into one colossal landmass. Oh, and the 5-continent model? You've actually seen it. That's exactly what the 5 interlaced rings on the Olympic flag represent. They just exclude uninhabited Antarctica. So what's the big takeaway here? Well, a continent is really just a human cultural construct. It's deeply influenced by our history and conventions rather than any strict, undeniable physical borders. This confusion really boils down to a massive clash between two totally different ways of looking at the Earth. On one side, you've got cultural geography. This relies on convention and, let's face it, pretty arbitrary human borders. Take Africa and Asia, for instance. They are technically connected by a continuous landmass. Literally, the only thing separating them is the human-made Suez Canal, which is incredibly narrow and shallow. Yet culturally, we just casually define them as entirely separate continents. On the flip side, we have scientific geology. Geology relies on strict physical boundaries based on what the Earth's crust is actually made of. Geologists, they don't really care about shallow canals or historical human politics. They just care about rocks.
So, let's put the politics aside and shift our focus strictly to the science. In Section 2, the geological truth, science over convention. See, according to geologists, coastlines and sea levels absolutely do not define a continent. Why? Because shorelines are basically just accidents. They change constantly as sea levels rise and fall over time. Instead, geologists look at what lies deep beneath the surface. To them, a true geological continent actually has to meet 4 incredibly strict criteria. First, it has to have a high elevation relative to the surrounding ocean floor. Second, it needs a diverse geology. We're talking a wide mix of rock types, igneous, metamorphic, and sedimentary. Third, the crust itself must be thicker and less dense than the surrounding oceanic crust. This thickness and low density is absolutely crucial because it allows this massive landmass to literally float higher on the Earth's dense underlying mantle. Think of it like a really thick raft. And fourth, it must have well-defined limits and a massive area, specifically over 1 million square kilometers.
Now, here's where it gets wild. When you apply those strict scientific rules, you don't get 7 continents. You get this number: 8. Yep, in 2017, a submerged landmass called Zealandia, which actually pokes out from the ocean primarily as New Zealand and New Caledonia, was officially recognized as the Earth's 8th geological continent. It hits every single one of those 4 criteria perfectly. But because the vast majority of it just happens to be currently submerged beneath the ocean, it's been totally hidden from our conventional everyday maps. It completely shatters everything we thought we knew about what actually makes a landmass a continent.
But hey, the surprises definitely don't stop at how many continents there are. Let's move along to Section 3, the continental drift mystery.
Okay, so having established what a geological continent actually is, a thick, buoyant slab of continental crust, we need to drop a massive historical bombshell. These massive crustal rafts, they actually move. Let's walk through the timeline of how we figured out this scientific mystery. Way back, as early as 1596, a cartographer named Abraham Ortelius noticed something weird. The puzzle piece fit of the coasts of the Americas, Europe, and Africa. They just looked like they clicked together. Fast forward all the way to 1912, and a scientist named Alfred Wegener proposes a totally radical hypothesis: continental drift. He basically suggested that all our continents were once joined together in one giant supercontinent called Pangaea. Now think about how absolutely crazy this must have sounded back in 1912. The idea completely languished for decades.
It actually wasn't until Arthur Holmes suggested mantle convection in 1931, which is the idea that the Earth's molten interior is turning and circulating, and the final confirmation of plate tectonics in the 1960s that the world finally understood how this was even possible.
But for the longest time, Wegener's idea was treated as an absolute joke in the scientific community. There is this fantastic quote from the legendary broadcaster David Attenborough that I love. Recounting his time at university in the late 1940s, he said, "I once asked one of my lecturers why he was not talking to us about continental drift, and I was told, sneeringly, that if I could prove there was a force that could move continents, then he might think about it. The idea was moonshine, I was informed." I mean, wow. That perfectly captures just how fiercely the fixist scientific community, the folks who firmly believed the continents were permanently bolted in place, rejected Wegener's paradigm-shifting idea.
Though, to be completely fair to those skeptics, Wegener's hypothesis did have some massive flaws. For one thing, his math was wildly off. He calculated a continental drift speed of roughly 250 centimeters per year. To put that into perspective for you, the actual accepted rate today for the Americas separating from Europe and Africa is about 2.5 centimeters per year. So, yeah, he was moving things 100 times too fast. Secondly, and much more importantly, he completely lacked a valid physical mechanism. He tried to suggest that the centrifugal force of the Earth's rotation pushed the continents through the ocean floor, but basic calculations quickly showed that this force was nowhere near strong enough to do that. Without a believable engine to actually drive this massive movement, his theory was just broadly rejected.
So how exactly did moonshine become universally accepted textbook science? Let's get into Section 4, Proof of a Moving Earth, the Final Evidence. Turns out the missing piece of the puzzle was hiding deep underwater all along. In the mid-20th century, scientists like Maurice Ewing and Robert S. Dietz found this massive winding system of mid-oceanic ridges. This incredible discovery led to the concept of seafloor spreading. This is literally the creation of brand new oceanic crust right at these mid-ocean ridges, driven by those convection currents deep down within the Earth's mantle. It finally proved that the English geologist Arthur Holmes was absolutely spot on. The Earth's interior is fluid, it's scorching hot, powered by radioactive decay, and this heat continuously dissipates, literally moving the crust at the surface. Let's break down how this builds into what scientists lovingly call the conveyor belt hypothesis. It's like a giant factory floor. Step 1. Magma rises up from weak zones deep within the Earth's mantle. Step 2. It erupts right at the crest of those mid-ocean ridges, cools down, and forms brand spanking new oceanic crust. Step 3. As this new crust is formed, it gets magnetized by the Earth's magnetic field, and then it's slowly displaced outward, shoving the older crust out of the way. During the Cold War, when scientists were busy mapping the ocean floor, they found these zebra-like stripes of normal and reversed magnetic polarity radiating outward from these ridges. This was the undeniable smoking gun. The oceanic crust was continuously being created and moving outward like a giant conveyor belt, fundamentally shifting the positions of our continents over millions of years. And suddenly, all of Wegener's old, dismissed evidence just clicked perfectly into place. The physical proof is honestly beautiful. We have matching fossils of the freshwater reptile Mesosaurus found in both Brazil and South Africa. Now, this is an animal that absolutely could never have swum across an entire salty ocean. We have continuous Permo-Carboniferous glacial striations. These are giant scrape marks from ancient ice that show glacial flow moving away from the equator, and they line up perfectly across South America, Africa, India, Antarctica, and Australia. And of course, those incredibly complementary puzzle piece coastlines. Gondwana and Pangaea weren't just scientific fairy tales, they were absolutely real. And the coolest part? We aren't just relying on ancient, dusty rocks and fossils to prove this anymore. Today, we can literally measure continental drift in real time. Modern GPS tracking confirms without a shadow of a doubt that the tectonic plates are actively traveling as we speak. For instance, super-sensitive sensors show that Maui, in Hawaii, has moved 84 centimeters longitudinally over just 14 years. When you connect that sort of movement to a massive geological timescale, it is just awe-inspiring. The ground beneath your feet right now isn't fixed. It's a dynamic, living, moving raft floating on a deeper, churning mantle. Which leads us to a pretty mind-expanding thought to end on today. If the continents are currently moving right this very second, and they are, what is the map of the Earth going to look like millions of years from now? Think about it. The oceans are going to shift, totally new supercontinents will form, and the geography we know and recognize today will be completely, utterly unrecognizable. So the next time you happen to look at a globe or a map, just remember, you are only looking at a temporary snapshot in the grand, ever-shifting history of our incredible planet. Thanks so much for joining me on this explainer, and keep exploring.